All right, so I guess we can start the webinar today. I'm going to be the presenter of the webinar. I'm the co-founder and CEO of SuperAnnotate. My name is Vahan, and before starting SuperAnnotate, I was doing PhD research in KTH Sweden. It's Technological University of Sweden, if you're not aware of it. So today's topic is going to be very, very close to my heart, which we will really talk about the future of LLMs. And it is becoming more and more important that people are coming into realization that the data is the main bottleneck of the current LLMs. And we would be covering the data perspective of those future of LLMs. So a little bit about ourselves. I told you about myself. We have been a company that started in 2019 by two PhD researchers. It was me and my brother, Tigran at the time, and then we had two late-stage co-founders, David and Jason, joined us later. So far, we have raised around $22 million from European and Silicon Valley investors and have a team of about 80 people across US and Europe. And overall, if you're looking at the company, at the ratings about the company, so we have been a top-rated platform within the MLOps space, within the data labeling space, and the image recognition space. Those are the categories in G2 software rating platform. Then there is all the other places that you can go and check about us. And kind of enough about us. Overall, what we're doing, so this is like SuperAnnotate in a nutshell. This is specifically our LLM product. The first component that we're addressing within the LLM space is called prepare and fine-tune. So as many of you know that fine-tuning is a very, very important aspect of LLMs, which is creating that data set to be able to train the LLMs. The second aspect that we're addressing is called explore and evaluate. And evaluation actually is one of the super difficult parts. Within the LLM space, we started from computer vision and did a lot of evaluation there. But then as we turn to LLMs, we have been facing a lot of challenges to enable our clients to create evaluations. Once you have that questions and answers, let's say, exploring those data sets, understanding them is becoming an important aspect of that. So we're kind of covering that. The third aspect is, again, software-wise, we're helping our clients to orchestrate and automate more complex pipelines, meaning that if you're trying to put triggers and custom actions in between different things, then you're able to do it in our platform. And then here is a small snippet of how those things can be done on our side. And then the last component, which is also super important, is called WForce, which expert workforce in general is one of the biggest bottleneck of creating highly scalable data sets that will enable the new ChatGPTs of the world. So we have been helping our clients to scale towards hundreds of people, really high-skilled people, whether it's language expertise, law, accounting, all the other expertise that people want. So we're able to support that. And basically, by covering those four aspects is really enabling us to talk about this topic. What is the future of LLMs? Why do we see a certain way? And since we're dealing with several foundational model building companies, we're able to kind of articulate what are the biggest bottlenecks that we see on our side that would be the challenges of the future. All right, so one very big and bold statement would be the publicly available internet dataset has already been used by several foundational model companies. And as that dataset has been used already, then very natural question that is arising is, so what's next? How are we going to further improve those large language models? since we already used those publicly available internet data sets. And before kind of answering that question, let's do a big step back and talk a little bit what are large language models. So this is a very simple graph that is showing that we have a text input within the large language model, and then we have that language model that is doing their magic, and then it is able to perform and give us an output that is a text base in general, and that output is generally done by something called vector embeddings or numerical representation of those text inputs that is matching the output of in terms of an answer. And largely, those large language models were popularized by this paper called Attention is All You Need. This is a around 6-year-old paper at this moment, which is more or less found a way to create a parallel training, because in the past we were not really able to use GPUs to perform very large scale trainings for those language models, and the industry just boomed afterwards. Cool. Let's see. Now, let's start from the beginning. The easiest and way of understanding the LLMs, it's called question answering. So you have an input, as you have seen in the previous slide, and then you have an output. So input is sometimes it's called prompt, and the output is called the answer. And when you're dealing with those type of prompt and answer techniques, then within the LLM infrastructure, those LLMs are quite accurate, especially the new ChatGPT 3 and 4, or the models provided by Cohere or Anthropic, are providing very, very accurate answers oftentimes. But then there is still not really the best in terms of reliability. There is problems with hallucinations, and the accuracy in general are not really that reliable of putting those models into the production, because when you have a production code or any type of answer you want to generate, you want to make sure that it's 99% plus accurate. And as this is the simplest form, so I'm going to do some references how those form building will look like in our platform. So here on the right side, you can see that I have different components in our platform, and then I can kind of build those UI that will enable you an input that will be my prompt. I will put a button as a generate button, and then the answer will appear as a text box. So it's very simple and straightforward to organize question answering type of UI if you want to use our platform. Now, there is this more complex concept called chain of thought prompting. And what this is really allowing you to do is to have your input, break down your input into similar type of patterns or several building blocks, and then provide the output. And here you can see that there is this small snippet where before asking the question, it gives a couple of similar examples and the answers of those examples. So as you're giving this to the input, then the large language model is better able to kind of follow those instructions and then give the output. And then here you can see that the LLM accuracy is increasing in general based on the input size, but then the input size when you're entering to your large language models, the cost is becoming higher because it requires more tokens to be entered to your language model. And a similar type of setup, if you're trying to do it in our platform, then it's very, very simple. So you put the input, you put the button, you put as many small blocks that you want. And then again, you put the output as a text box for you to create similar type of chain of thought prompting. Now, as people are trying to further increase the accuracy of those LLMs, you can also try something called the self-consistency with the chain of thought. And what this is really doing, it's kind of doing the same chain of thought prompting several times. And then at the end of the day, it's doing a majority voting. And this would be similar if you're in machine learning, if you're trying to build a random forest classifier, then you have individual small weak trees that are not accurate, but when you're combining the not accurate answers together, then you're getting something a lot more accurate than by just taking an answer of one of the outputs. And then you can see that here I even further make it slower. First of all, my costs are growing as I'm trying to do this self-consistency because I run the same input several times to get different outputs. And then the latency is also decreasing with those language models. And in some application, the latency is a very, very important factor because if you're trying to chat, for example, something that is between a few hundred milliseconds to a few seconds is the maximum that generally people can tolerate to get the answers. And again, similar type of setup that you can do it in our platform, which I will not really cover that much in detail. All right, so the last concept that we're going to cover is called a tree of thought. And this is where it becomes very, very interesting because now instead of just blindly doing a chain of thought several different times, at the end of each block, I'm going to put an evaluator of my answer or of my semi-answer. And based on that small block, I will decide whether I want to kind of go deeper and repeat that several times, or maybe if my answer is not good, then I will evaluate and I will not really go deeper into this. This is a very common technique, actually. So if you have been in machine learning, then AlphaGo was some big breakthrough about 8 years ago that was using a Monte Carlo search. And this is exactly a similar type of Monte Carlo search that is making a step, evaluating their step, and deciding whether it needs to do an extra step or it needs to kind of change the direction, go back and do some other steps. And if you have been following the recent news, there is this big buzz about Q-star, which is an algorithm that was potentially causing all the OpenAI, should I call it drama? I guess, yeah, let's call it drama, caused all the OpenAI drama. And at the end of the day, they were saying that they found some type of Q-star algorithm, which is a mix of A-star, which is a search algorithm, together with Q-learning, which is trying to solve Bellman equations. That was a really old algorithm that is trying to find an optimal path. And as a result, they will be able to kind of come closer to something called AGI. And this is similar type of thing that what we were able to achieve in 2015 with AlphaGo. Again, similar setup in here. And what I'm showing you on the right side in here, that each of those actions that have been created as a UI on our side, you can add a very small Python snippet to perform your evaluation. And based on this evaluation, you will understand whether you kind of want to repeat from one cell or go to several cells and so on. Cool. Now, why am I talking about this? I want to quickly do a demo and then give you the first perspective of what people should concentrate when building their large language models. And this is more or less a big trade-off between latency, cost, and accuracy, which I will discuss in a bit. But before going there, let me kind of do a very small demo of how that would look like basically in our platform. So let's say we're going to create a new project, name our project, say webinar. And in our project, you can see that now I have this UI that I am able to choose what type of component should my UI look like. Let's say I want to create a model comparison UI. In that case, I can put a text input, and then I can put a button that will be for my generation. So that will be this button component. And then I want to put two different text outputs because I want to compare those text outputs and then rate them. In order to put two different text outputs, now I'm going to put a grid component, and then within that grid, I will have a text area here and a text area here. And I want to rate both of them, so I will use the rating component in here. And here we go. So this will be my new UI that will help me to do the LLM evaluation for this specific use case. But as you can imagine, you can do tree of thought, chain of thought, self-consistency, very simple question answering, and anything that you can imagine building yourself, any type of customization. And as I'm clicking next, I was telling it before, I have this very small Python code in here that I can input OpenAI APIs, all the other foundational model company APIs, where I can put all my API keys in the variable section, and then use them as the input to evaluate my new models and so on. Cool. Let's go back to our slideshow and discuss one dimension that people should really concentrate when building large language models, and where the future will be. And this is an idea that I circulated earlier. There is a big trade-off between the cost, latency, and accuracy, and how you're gonna decide what you need to build and which cost in which way latency and accuracy is going to be one of the big factors and challenges that people will face when building those LLMs. And all of this is really depending on the data that you have, because if you have an LLM and you perform a very accurate fine-tuning, then with that fine-tuning, you can decrease your costs, you can increase your accuracy, you can decrease your latency, and things like that. And then so far, what we have been talking about, like simple text input and the simple text output, but it is not really always that we have a simple text input and a simple text output. And the reason I'm saying this, that you can see that GPT-4 is already able to do text-to-image retrieval generation. You can write a text and it will give you a CSV file. It will text. So it's becoming very, very complex, the output. And when you're thinking about training and fine-tuning large language models in this case, then performing reinforcement learning human feedback, performing reinforcement learning AI feedback, or supervised fine-tuning, all three components are becoming super, super hard to manage. And the second dimension when you're thinking about the future of LLMs will be, where do I want to end up within this reinforcement learning, human feedback, AI feedback, and supervised fine-tuning? Because all of these three components are really hard to understand and get very good results. At the same time, you sometimes need to mix them and further decrease the costs of your labeling or those human feedback costs, because as we're entering the language model space, you need more and more highly qualified people to perform those tasks for you, which sometimes they can be more expensive than you or me performing just a labeling task. So let's quickly wrap it up and then say what we discussed during this webinar. It is very, very important to understand the tree of thought concept, and then how people are having difficulties with the evaluation, with understanding more deeper concepts, and this is affecting on big triangle in here, which is the cost, accuracy, and latency. At the same time, when you're trying to build very large data sets, understanding the trade-off between the human feedback, AI feedback, and supervised fine-tuning is also becoming very, very hard. And when you're trying to take all these 6 variables and optimize them, this is where the challenges appear. And this is more or less is a data infrastructure problem, because the models that are up there are more or less fixed. And then if you can decide the trade-off between these 6 and build the best data sets, then you will more or less achieve the GPT-4 level accuracy with a lot of data sets that will be inputted to your model. And I don't really want to take too much of your time, and would be happy to answer any of your questions. So let's see. We have 2 questions. So the first question is, which method is used for the latest LLM chain of thought or tree of thought? This is really up to it's really up to the engineers to design. So when we're doing it, we just give you the building blocks for ML engineers to connect any type of API that you want. At the end of the day, more accurate is your initial API would be, better you can improve that API, but you should be able to experiment and do it yourself. But on our side, we're giving those capabilities. Okay, so second question is, how do you generalize the evaluation through the tree of thought to handle any prompt? This is actually, it's a question, it's a very tough question to answer, because there is not really good metrics as we had in computer vision. Even in NLP, we had some type of method to do evaluation. In some case, generative models are really hard to evaluate by just an AI model. And sometimes you can use a very accurate AI model to evaluate the smaller ones, the output of the smaller ones. And this is where AI feedback can kick in. And if you're trying to get something much, much better than GPT-4, then the evaluation is going to be super tough, and it's not really a solved problem. But if you're trying to optimize your fine-tuning to get faster model with more fine-tuned data set, in this case, you can use either a larger and bigger model to evaluate, or you can use some type of model, give them different ways to hack your answer, and then see whether the evaluation is breaking and so on. So the next question is, again, it's about the reinforcement learning AI feedback, but I think I answered this question because we are kind of enabling you to put any API that you want, perform the rating and so on, and then gather the rating of those data sets, and later do some queries on top of them, visualize better. These are the platform demo that I haven't shown. And then whatever I have shown you was more or less like 10% of our platform, but overall happy to, if you're kind of are very keen of learning more, feel free to request a demo, and our team will be happy to show you. We have one more question related with thoughts of what are our thoughts on cost benefits of fine-tuning versus RAGs. So you can always get cheaper with fine-tuning, and the RAGs are very often working on the simplest use cases. But if you have tried RAGs yourself, I wouldn't really say that the RAGs are to the point that it is able to very quickly recover the information that we need. I think there is still a huge development that we're gonna see within the RAG space. And for now, I would bet my options on the fine-tuning. And even with RAGs, RAGs are generating your answers based on the embeddings. I would just create a better fine-tuning, so that will create better embeddings. As a result, I will be able to recover my answers in a better fashion using RAGs. Right, so let's see. We have another question related with what is the future of LLM in terms of new methods and new directions? Let me see if I understand this question. So the new methods, kind of the most recent buzzword that is not really known to the public, which is that Q-star is more or less trying to adopt some of those AlphaGo Monte Carlo search techniques within the LLM space, right? So I would say that this is really the most prominent future that people should try, that will come in terms of the latency decrease. And as the latency will decrease, people will try to kind of create faster algorithms to enable the better accuracy and so on. So next question, is there a way to generate automatically the data sets for fine-tuning using our platform? Generate automatically data sets. Yeah, absolutely. So you can use our platform for generating those data sets. You can generate similar examples or simply use our Python SDK to generate some of your own data sets and then kind of upload it in our platform and visualize it better, organize your data set better, and so on. Okay, let me answer one more last question, which is a little bit, it includes a paper in here, but I don't know if I've seen that paper. So do you have any tools to help to make sure fine-tuning doesn't leak training data? Fortunately, this is a topic that I'm not really familiar with, so I should probably pass on this question, but this is a very good question, and I would like to post the paper to the public if you folks heard about this. So let's see if I can post it in here in the chat. I don't know if you see it. But yeah, thank you so much for attending the webinar. Hope this was useful. Feel free to ping us if you have any more questions. We are helping over 5 different foundational model companies to build their best-in-class foundational models, and happy to help you as well to fine-tune some of the ideas that you have around the LLM space. Have a great day. And cheers. Bye-bye.